previously we had graphed trig functions in degrees, and we ran through a series of questions that we answered before we actually graphed it. So let's go through this particular example where we're graphing f of theta equals 1 plus 3 sine 2 theta, right? Is this vertically flipped? No. What's our amplitude? It's 3. Our period, well, our period is, remember that the period formula is equal to 360 degrees divided by b, and in this case b is 2. So our period is equal to 360 over 2, which is 180. So our period is 180 degrees, and then our midline is y equals 1. So when we graph this, right, our midline is 1, right, and so we go up 1, and I just put the little dotted line here so I know what my midline is, and I have a max of 4, right, because I go up 3, and then I go down to negative 2, and my period is 180, so I need to mark up my graph here with my quadrantal angles. This is 45 and this is 135, and I am graphing a non-vertically flipped sine wave. And so I start in the middle, I go up, back down to the middle, down to the minimum, and back up to the middle. Up here, down, I want to go through that point right there, down to the bottom, and back up. And that's one period of my sine wave. Okay, now we are in radians. So the only thing that's different is that, remember that instead of our period being 360 by default, our period in radians is now 2 pi over b. Okay, and so let's look at an example of the same graph in radians. So everything is the same. Is this vertically flipped? No. What's the amplitude? It's 3. What is the period? Well, the period, remember that our period formula is equal to 2 pi over b. B is the exact same thing. That's b, right? So in this case, we have 2 pi over 2, which is pi, and that makes sense because our period from before was 180 degrees, and 180 degrees is equal to pi radians. Okay, so now our midline is y equals 1. So let's graph this. It starts out exactly the same, right? I draw my midline, right? And then I find my max, which is 4, and my min is negative 2. Now here's the thing. What's new for this one, and I'm going to put it in blue, is how I come up with my, well, 5 key points is new, but how I come up with my quadrantal angles. Now, I'm not horizontally shifted at all, okay? But pi is my period. So one thing that you can do is you can figure out what a quarter of a period is and add that to your starting point. Here my starting point is 0. So a quarter of a period, so 1/4 of a period, right, is this period right here, pi divided by 4. Alright, so this point right here, right, is 0 plus pi over 4. And so it's pi over 4. And if I take this number and I add another pi over 4, right, that's 2 pi over 4. So pi over 4 plus pi over 4 is equal to 2 pi over 4, which is pi over 2 in simplest form, right? And if I wanted to add pi over 4 to pi over 2, that's the same thing as pi over 4 plus 2 pi over 4, which is 3 pi over 4. So this is 3 pi over 4. Okay, so I think for us the quickest and easiest way to do this is to figure out what a period is, right? Then take a quarter of that. And from your starting point, just keep on adding a quarter of the period and simplify your answers. Okay, and then we can draw our graph. So here we have 1, we go up to 4, back down to the middle, down to the bottom, and back up to the middle here. And so these points right here, this, and this are what I'm referring to as my 5 key points. And you just read them off in order, right? Like this one right here is the ordered pair 0, 1, right? So basically your ordered pairs are in the form theta, f of theta. Okay, so then my second point right here is pi over 4, 4. This next one here is pi over 2, 1. My next one here is 3 pi over 4, negative 2. And last but not least, my final point here, and that is pi, 1. And so those are my 5 key points. So in the next video, I'm going to work out some more examples of this.